We have so far studied 20 principles of TRIZ, but I told you that in order to take care of the 39 technical specifications and the contradictions between them, we need 39 plus 1 principles, and in fact 40 principles are what I am going to talk about. So, today we will start from principle 21, which talks about skipping. So, skipping is an important tool for any hazardous process, and the rule here is that conduct a process or certain stages, example if it is destructible, harmful or hazardous, at high speed. Just you think of the dentist's drill, they use it at a very high speed to avoid the heating issue. Then think of the laser eye surgery. It is done at a very high speed so that the laser cannot do harms to the other tissues or go deep into it. One very interesting thing we always come across is in terms of cutting plastic, because if you try to cut a plastic, it is also subjected to plastic deformation, and as a result you may not get, if you always try to do this process, you will see you may not get a very sharp cutting out of plastic, unless you do this process so very fast that the heat does not get any chance to propagate and hence would not create any plastic deformation or deformation, thermal distortion of the shape. Again, similar thing is true for other viscoelastic materials like break toffee with an impulsive blow from a hammer, drop forge technique. Flash photography is also based on the same principle. And then there is again a very important type of application, and that is for the flexible rotors. For the flexible rotors, we know that there will be many resonating modes. Now, if you are trying to rotate a flexible motor from 0 RPM to some 25 or 30,000 RPM, in between there will be many resonating modes. So, if you gradually increase the speed, chances are very high that all these intermittent resonating modes will get affected, and that would create resonance that would possibly will be very harmful for the flexible rotor, if not catastrophic. So, one way to actually operate such systems, the supercritical shafts, is to run through the resonant modes very quickly. So, that means if I consider a particular flexible shaft, and let us say these are the natural frequencies and this is the transfer function, and it would have many such resonating modes. Now, let us say I have to reach somewhere here. This is my point of omega that I want to reach. This is my omega target, that is the frequency of rotation. So, you have to do a frequency sweep very fast from the 0 hertz to this point, so that all these resonating points would not get any chance to disturb the system. The next interesting sounding principle is principle 22, that is blessing in disguise. Many times we think that certain things are harmful, but actually if you can control the harmful factors, harmful effects of the environment or surroundings, even you can achieve a positive effect out of it. Let us say we know that heat is a waste, but if you can design a Stirling engine, then this waste heat can be used in terms of generating some useful work. Similarly, we say that sound and vibration are waste. They create noise. They also destroy the structure because of the fatigue. But if you know how to transfer these mechanical energy from noise and vibration into an useful electrical energy, which we call energy harvesting devices, if we can design, then you can actually get something useful from the apparently a waste thing. Similarly, eliminate the primary harmful action by adding it to another harmful action, joining up two harmful actions together to create something which will be neutral, like add a buffering material to a corrosive solution, example an alkali to an acid. Use a helium oxygen mix for diving to eliminate nitrogen necrosis and oxygen poisoning from air. So, you use a helium oxygen mix, not a nitrogen oxygen mix. So, you add two harmful elements together, so that they actually sort of interact with each other. Third possibility is amplify a harmful factor to such a degree that it is no longer harmful. Well, we always know that the noise is harmful for us, but we also know that there is a intensity level of noise. If you can go beyond that, then if the frequency is beyond that level, then you won't be able to hear it, because human auditory range is not going to capture if it is beyond a particular level. So, that way the harmful effect would not be perceived. There are many things. For example, use a backfire to eliminate the fuel from a forest fire, or use explosives. This you will see many a times, that wherever we actually extract the oils, you will see that there is a continuous fire, and that fire is nothing but to blow out the oil well, additional things, so that that does not create any environmental problem. Laser knife, laser based, all these surgeries use this principle of a harmful factor to such a degree that it is no longer harmful. So, that is principle number 22. We have to keep in mind, that is blessing in disguise. I will now go to another very, very important principle that we use mostly for intelligent systems. This is principle 23, which is related to feedback. So, principle 23 is feedback, and this is important, like for any active system. If you have a feedback, then you can actually correct the system from the feedback, from the sensor. So, first point is introduce feedback, referring back, cross checking to improve a process or action. So, that any example you think of it, like automatic examples, automatic volume control, or aircraft autopilot, or engine management system of an automobile, or thermostat for this heater control, geyser temperature control, process controls, feedback is extensively utilized. But there can be also a case further, that is, if feedback is already used, change its magnitude or influence in accordance with the operating conditions, like change the sensitivity of autopilot, or change the sensitivity of a thermostat between the heating versus cooling, or use different types of complex feedbacks like PID controller, proportional integrator, integral and derivative control. So, that is another way that feedback is present, but you make more meaningful use of the feedback. So, that is principle number 23. Principle 24 we are going to talk about is about intermediary. Use an intermediary carrier article or intermediary process. I always give the simplest example for this principle. Suppose you kept something very hot in your oven and you have to take it out fast. What would you do? Your hands would not be good enough to do it. So, you have to put on a gloves. That gloves work as an intermediary, so that it takes the thermal load, whereas you control the trajectory or the movement of the object. That is the essence of principle 24 or intermediary. Here there can be two applications of this principle. A is use an intermediary carrier article or intermediary process, and then there are many. I have just given one. Well, you think of it, saving from hot objects or something, you use a coaster, or dual period during a manufacture process operation. In manufacturing we use the dual period. Use a chisel to control rock breaking or sculpting process, that is an intermediary. Your hand would not be able to do a sculpting. So, the chisel is the intermediary between you, your creative activity and the rock. Same thing you can extend possibly for playing music, that play guitar with a plectrum. Now, B is interesting intermediary, merge one object temporarily with another and which can be easily removed, like the say joining papers with a paper clip. You are using an intermediary object here, but you can remove it also easily, or introduction of catalysts into chemical reaction, abrasive particles that would enhance the water jet cutting. You would see that we use these sort of the re-entry vehicle, okay, for astronauts to come back. Now, here the re-entry vehicle is the intermediary which saves the astronauts from the very high heat and all other environmental effect, but at the end you just take the re-entry vehicle away and use it again for another re-entry and the passenger gets detached. So, merge one object temporarily with another in order to gain some advantage out of it, and then you do this, you can do this process repetitively. The discovery of space shuttle, that is why is a very important thing, because the shuttle takes you to space and come back. So, it is a temporary engagement, it does not stay with the people, the astronauts, and then it is used again and again. So, this is the principle 24 of intermediary. Principle 25 I am going to talk about is of the self service. Self service is important, particularly it is important from the sustainable design point of view. Okay. So, just you think of one very simple example, that is the cone ice cream that you always take. Now, after you consume the ice cream, you are able to consume the cone also. So, as a result, it would not create any environmental pollution. So, the cover of the ice cream is actually giving you a self service. Now, point A here is that make an object serve or organize itself by performing auxiliary helpful functions. And then there are many examples of it, I am just giving some examples. Self aligning, self adjusting seal, self locking nuts for manufacturing, these are very important, self cleaning oven, glass material. Not only that, self sharpening of some of the blades, right, that is used for, let us say, for the hair cutting or for the even for the grass lawnmower, self sharpening, self repairing structure, self healing structures. These are all the self service. That means, you do not need any external service in order to sort of maintain the structure. Okay. I give you a very interesting example in this direction, that is related to self healing. So, in self healing, what can happen is that you imagine that there is a structure, okay, and this structure is going to have some sort of special fibers, let us say something like a carbon fiber in it. And let us say this structure is going to get some cracks. Now, if these cracks happen, then there is stress concentration in this region, and that can actually create a voltage, and there is generally an electrode cover in the two sides of the structure, and because of this voltage generation here, there is a electric field potential change, so that these elements can migrate and make this part stronger, so that it would not allow the crack to propagate. This is a very new principle of automatic healing in aircraft, and that is an example of self healing. Now, use of waste resource is another way of doing it. Use of waste resource, energy or substances, like use heat from a process to generate electricity, use animal waste as fertilizer, and all these things. So, waste resource, it can also be considered as a principle of self service. Principle 26, we need not take it literally, but it is very, very important because it talks about copying. So, what does this copying means? Of course, it is not copying in the exams. Copying is a very important principle that even nature uses every now and then. In that sense, all our offsprings are actually DNAs copied from us. All our growths are actually the mother DNA getting copied multiple number of times. So, copy is something that happens in the nature every now and then. Now, here we have kept three types of copying principles. A, instead of an unavailable, expensive, fragile object, use simpler and inexpensive copies. Imitation jewelry, it is a copy of it gives you the effect of jewelry, but it is not essentially a valuable material, and that way it is also sufficiently robust, because the most of the jewelries like based on gold etc., they are not so robust. And then there are many such examples you can think of. AstroTurf, instead of the grass which is very fragile, you use the artificial grass today. The crash test dummy, instead of testing on anything living, you put a dummy. You remember that when ISRO has sent the mission for testing the astronauts' condition, they put a dummy robot, so that the robot can be spared, but you will get all the important information that the different environmental factors that comes inside the system. UAV excludes the pilot, so no risk, but you are copying an aircraft type of an action and doing the same thing. So, this is use of inexpensive copies. Other possibilities, you replace an object or process with optical copies. So, like do surveying from space photographs instead of on the ground, or measure an object by scaling measurements from a photograph, laser anemometry, virtual reality, virtual mock-up. So, all this entire virtual thing through the optical copies and later on through many other measures becomes important. One, of course, it is then cheaper, but also it would become sustainable, and it would also in certain times it becomes very valuable. For example, during the COVID time, optical scanning would actually help you not to come in close contact with the patient. Lastly, if feasible optical copies are already used, then as I told you that move to infrared or ultraviolet copies. So, that is something that that happens every now and then. So, thus the principle of copying is a very, very important principle that is used. Principle 27 that I am going to talk about is all about cheap, short-lived objects. That is our principle 27. So, you see, disposable, the word disposable has become so much successful today, and that is why, because it is relatively inexpensive. So, replace an expensive object with a multiple of inexpensive objects. Fountain pen used to be very expensive. Now, with the help of these dot pens, so to say, the ball pens, it becomes inexpensive and you get the same effect of writing. So, that is something that is used like very extensively, and that is also, remember, one of the source of major pollutions as well, because we get addicted to use these cheap short lived objects. So, disposable of course is one. Matches versus lighters, throwaway cigarette lighters, industrial diamonds used in cutting tools, sacrificial coatings components, post-it, or discarding these discarding sabot armor piercing rounds. So, all of these are cheap short lived objects. You design it knowing fully well that it will have a short lifespan, but it will serve the purpose. Okay? Nobody is talking about designing something which will be working for years. This will be like, you think of a birthday party, the things that you will use is only for a couple of hours. So, it has to simulate, it has to create an ambience only during that small span. That is what is 27. 28 is very close to our heart, and we call it mechanic substitution. Replace a mechanical means with a sensory like optical, acoustic, taste or smell means. So, replace the mechanical means by something which is maybe electromechanical. Use, in fact, next clause is even clear about it, use electric, magnetic and electromagnetic fields to interact with the object. Okay. So, the entire use of this something which we call smart materials, that is so important for an intelligent system, is you can think of it that these smart materials are the best example of mechanic substitution. Change from static to movable fields, from unstructured fields to those having some structure, like say magnetic resonance imaging. Use fields in conjunction with field activated particles. So, all are examples of mechanic substitution. So, basically you have certain tasks to do and there already exists a certain way of doing it, and when you substitute that way of doing by using other techniques like I said magnetic, electromagnetic or temperature or light, then that is the mechanic substitution we are talking about. Principle 29 is about the use of pneumatics and hydraulics. They are some of the very important elements in terms of actuator design, particularly high power actuators. So, use gas and liquid parts of an object instead of solid parts. Example, inflatable or filled with liquids, air cushion, hydrostatic, hydroreactive substances. So, what are the advantage of such a system? Well, one of course that you can quickly build it, it is less heavy. So, it is more deployable, almost all deployable structures are inflatable also. So, inflatable furniture. Then there are other things like hovercrafts or the gas bearings, acoustic panels which incorporates the Helmholtz resonator. Helmholtz resonator is like a, you can consider it to be a small chamber with a narrow kind of a exit in it. So, this specialty of this type of a chamber is that while these chamber mass can be modeled as a mass, the air containing here can be modeled as a spring, so that the Helmholtz resonator can give you a pure natural frequency. And using such kind of a thing, you can actually control the wave propagation, for example. Okay, so, that is pneumatics and hydraulics. The next principle I am going to talk about is flexible shells and thin films. As you know that almost all the advancements in terms of the structures, in terms of the housings that we design, okay, be it automobile, be it aircraft, our direction of work today is how to make it lighter and lighter in weights. In order to do that, naturally you have to go for materials which are less stiff. Now, that can give you double advantage, because if you use a flexible material like flexible shells or thin shells, then you not only reduce the weight, but also you can give an adaptive shape, particularly where this system is in interaction with fluid or air. Let us say something for a ship or something for an aircraft. This adaptive shape, that the flexibility can give, is something that is a boon in terms of the design. So, use flexible shells and thin films instead of 3-dimensional structures. So, like inflatable structures. Okay. One important thing I want to tell you, that you will see some of the examples getting repeated while discussing about other principles, and there is no wonder about it, because these principles are simply a spark point, an ignition point for innovation in your brain. They are not per se, they are not like mathematical formulas. They are not even like the axiomatic design axioms, which cannot overlap with each other strictly. Here the principles can overlap. That is why the examples can also overlap, but these principles are kept so that you can keep in your mind the connectivity. Connectivity is very important here. So, as I was telling, that this inflatable structure is an example in that way, which has overlaps with the self service. And then other type is isolate the object from the external environment using flexible shells and thin films, like say bubble wrap, bandage, all these things. These are examples of principles of flexible shells and thin films. Now, similar to these, another structural innovation that is used extensively is related to porous materials, because that is principle number 31, make an object porous or add porous elements. It is particularly useful when you want to make something light, and when you want to create a thermal insulation, or when you want to create something like acoustic or absorption. So, drill holes in a structure to reduce the weight, that is one way of a broad way of increasing porosity. Foam metals, for example, or use sponge like structures. And secondly, if an object is already porous, use the pores to introduce a useful substance or function inside the pores, like use a porous metal mesh to have some weak kind of a structure, okay, and that is used for pulsating heat pipes, or store hydrogen in the pores of palladium sponge, because you know that palladium can absorb the hydrogen, and desiccant in polystyrene packing materials, medicated swabs or dressings. So, thus porous material has extensive applications where you want to enhance the surface area in order to increase absorption, be it material absorption or be it the absorption of let us say the energy and then dissipation of the energy. Last principle that I will discuss now is the color changes. The color change, like all these systems that you see biologically, okay, they extensively use the color change principle, okay, starting from let us say the lizards, okay, or the leaves. This example is there are many in nature. Change the color of an object or its external environment, okay, like say use color changing thermal paint to measure temperature, light sensitive glass, use color for camouflaging, employ interference fringes on surface structures, color changing in plastic, so that you can sort of figure it out that whether it is at high temperature, particularly for child feeding kind of cases, child feeding spoons. Then not only the color change means change of color from red to blue or blue to green, etc. Change the transparency of an object or its external environment, right, like use photolithography or smoke screen. In order to improve observability of things that are difficult to see, use colored additives is something that we use. For example, there is a very popular technique called PIV in fluid mechanics, flow visualization, particle image velocimetry. They use colored particles, so that you can see that how a sort of a fluid that you cannot see, a colorless fluid, how it interacts with a structure, and change the emissivity properties of an object subject to radiant heating. So, use of black and white colored panels or paint object with high emissivity paint in order to be able to measure its temperature. So, like that, color change is very heavily used in many different products. This is where I will close today's discussion, and in the last lecture we will conclude with the TRIZ. Thank you.